Quadratics. This is part one because later on in the semester we'll do a thing called the quadratic equation. But I'm gonna give it to you right now. We're not gonna use it necessarily for a while, but I want you to see it. So I want to remind you that the standard form of a quadratic equation is ax squared plus bx plus c. Okay, and in order to solve in a quadratic equation, it has to be equal to 0. It has to. If it's not equal to 0, it's going to be pretty tough to solve. Okay. So going back to that, using these a, b, and c, we're going to use something called the quadratic equation. So write that above it. Quadratic equation. Or quadratic formula, I guess, isn't necessarily an equation. It's a quadratic formula. And my pencil isn't letting me erase that. Quadratic formula. So it goes negative b, so negative of that second term, plus or minus the square root of b squared, so it's still b, minus 4 multiplied by a and c, all of that over 2 multiplied by a. The reason I give that to you now, just so that you can make this relationship start to stick in your head. You're going to have to start seeing things as this form. Okay. Alright, let's get into this note. So there's a zero product property. It just means that anything multiplied by 0 is 0. That's why when we have a quadratic that looks like this, x minus, let's see, x minus, make up a number, it doesn't matter, 5. X minus 5, and what did you say, Kason? 10. Say x plus 10, we'll do that. Now the zero product property allows us to set both of these equal to 0 because one of these inside of the parentheses has to be equal to 0 for the product of them to be equal to 0. Just a reminder, anything multiplied by 0 is 0. So what they're doing here is saying that one of these has to be equal to 0. So we let them both equal to 0 and see which one makes sense with our question. So that's what we've been doing, right? We end up solving these. We get a positive 5 and a negative 10. So this is just re-explaining the zero product property. So what we're going to start learning is different vocabulary. These are called zeros. We're kind of familiar with the vocabulary of zero because we had to do that in our graphing calculator. But let's do the example really quickly. So finding the zeros of a quadratic equation. The equation they give us is f of x is equal to 4x squared minus 25. You might notice that this is a perfect square up front and a perfect square in the back, and there's a minus in the middle. So what should that tell us about the factor of these? They are the difference of two squares, right? So if we've got a perfect square in the front and a perfect square in the back, we're going to end up with the difference of two squares. So that's nice for us because we can factor this easily. So when they give you instructions that say find the zeros of a quadratic equation, they literally mean set the equation that they give you equal to 0. So when you're finding zeros, set the output equal to 0. You might put in just a little inside the parentheses. That's the same as f of x. F of x is the output. Also, y is the output most of the time. So set the output equal to 0. And that's literally all it's asking you to do. Once we set it equal to 0, we just solve. So here's our equation, 4x squared minus 25 equals 0. And because it's a difference of two perfect squares, I can factor it rather easily. So I have the square root of 4 is 2, square root of x squared is x. And then I have the back side, which is 25, square root of that is 5. Up front, again 2x, and then the difference of two squares, so I'm having different sign, and plus 5 equals 0. Then to find the zeros, I just set each of them equal to 0 and solve. So first one, 2x minus 5 equals 0. Add 5, and we get 2x equals 5. Divide by 2, and we're left with x equaling 5 halves, or 2.5. I don't care how you write it. They're equivalent, so it doesn't matter if you leave this fraction or not. Okay, going back to the other one, I can set 2x plus 5 equal to 0. I subtract 5 from both sides. I'm left with 2x equaling negative 5. Divide by 2, same concepts happened. X equals negative 2.5. So my zeros are negative 2.5 and positive 2.5. Now, if it asks me where to locate my zeros, the location of zeros are at a coordinate. Okay, the location of zeros are at a coordinate, and it's where y equals 0. They are my x-intercepts. Okay, they are my x-intercepts. So it looks like this when you write down the coordinates. They intercept the x-axis at negative 2.5, comma 0, and positive 2.5, comma 0. Okay, so that's how you'll see them when you type them in your graphing calculator and you say find zeros, second calc, and then you find your zeros. You follow the instructions on your screen. That's how you'll see them represented in your calculator. But if it says identify the zeros are simply negative 2.5 and positive 2.5. Part B, that was part A. Part B says given the function 2x squared plus x, find the zeros. So again, I take my equation, I set it equal to 0, and I solve the best that I can. What can I factor out of this? X, right? So in order to factor this, I factor out an x. I'm left with 2x plus what? Just 1, right? So now either this x or this has to be equal to 0. So one of them is really easy to solve for. X equals 0. There's nothing I can do about that. I just know that one of these is going to be equal to 0. So I let the first one equal 0, and now I'm letting the second one equal 0. So I have 2x plus 1 equal to 0, and I have to solve for that. Subtract 1. I'm left with 2x equals negative 1 divided by 2. X then must be equal to negative 1/2 or negative 0.5, however you want to write it. So my zeros are at 0 and negative 0.5. If it wanted to know specifically the locations, then I would say 0, 0, which is the origin, and negative 0.5, comma 0. Okay. The zeros can also help you graph a quadratic equation. That's actually where they're most useful. Okay, next example. Any questions before we move on? Example 2 then. This says find the roots of this quadratic equation. I start seeing people get a little confused here, so please ask me if you need to get a question answered. So please pay attention to this one specifically, because we see ourselves saying, well, in order to make this equal to 0, the easiest way to do that is to move the x squared. But I never taught y'all guys to factor things with a negative out front. So in order for this one to work, I would say move everything to the left, because I don't want an x squared to be negative. I never taught y'all guys how to factor that. Didn't teach you how to deal with that. So I would move everything from here to the left. So in order to do that, I just move it and change the sign, right? Move it and change the sign. So I have x squared plus 2x minus 15. And it's equal to 0. So really all I did was add 2x to both sides and then subtract 15 from both sides. And that's what I ended up with, right down below. So it's now equal to 0. I can solve this because it is equal to 0. It says find the roots. So when they talk about roots, it's the same concept. We're going to factor it out and solve it by finding the roots. So now we have two different things. We have solving a quadratic, we have finding the roots, and we had solving for zeros. Roots and zeros you deal with the same way, okay? So here we go. I have this equation. I need to set up what I know first. It's two sets of parentheses, and of course they're equal to 0. I look at my back term. It's negative, so I'm going to have different signs. I look at my front term. It's just 1, so I know I'm just x's up front. Then I'm looking for factors of 15 that when subtracted, because my back sign's a negative, that when subtracted equal 2. So what factors of 15 when subtracted equal 2? 5 and 3, good. Now, which one of these, look at my middle sign, it's positive. Which one of these is going to end up with a positive? The 5, right? Because we want it to be positive. And I can quickly check this. Negative 3x when I multiply those, and positive 5x when I multiply those. I end up with a positive 2x in the middle. So it works. Then I set each of those equal to 0. So x minus 3 equal to 0. X plus 5 equal to 0. Finish solving. Subtract 5 from both sides. X equals negative 5. Those are really quick to solve. I don't actually expect to see this step. Y'all are advanced enough now that you don't actually have to write this step if you don't want to. Plus 3, x equals positive 3. Okay, so there are my two roots. And the same way, if it asks us to find roots, you say the roots are 3 and negative 5. Alright, take a look at that graph that they give you. It's a little chart that says zeros of a quadratic function. If you type the equations into your calculator, it's nice because it'll tell you how many zeros you have. Sometimes you will have no zeros. Notice it never crosses the x-axis. That's why I called them x-intercepts. It's because of where they cross the x-axis. So if it never crosses the x-axis, there will be no real zeros or no zeros. Okay? When we go over here, see that the vertex is just barely on the x-axis. So there's only 1 0 because the vertex is that 1 0. And then you'll see where it has 2 zeros, and that's where the vertex drops below the x-axis and it crosses in 2 places. Okay? So the zeros are just locating where the y is equal to 0, where the y is equal to 0. So when it says the word 0, what's really 0 is y. Okay? Let's go over a little bit of that definition that's underneath it. When a quadratic function has exactly one real 0, that 0 is called a double root. So this one right here is a double root. It means it shares the exact same spot on both answers. So we'll look at what that looks like in example 3. Example 3 gives us the equation x squared minus 6x plus 9 equals 0. Again, I have to factor, so I set up 2 parentheses, remembering that it's equal to 0. I look at my back sign, it says same sign sum. I look at my middle sign, it tells me that that same sign is going to be negative. So I put in my negative. I look at the front, it says my x's are going up here, just ones. And then I look at the back. What is a factor of 9 that when added together will give you 6? 3 and 3, really easy, good. So I notice that both of my products, or my factors, are the same. So I don't need to set up both of these equal to 0 because they're the exact same thing. It'd be pointless to do so. So this is called a double root. This is where you'll see one real 0. This is where our vertex is resting on our x-axis. Okay? So here, I would not solve both of them. That would be silly. So x then would equal 3. I have a root that is only one spot. It's called a double root, and it's at 3. Okay? So it says find the roots of each equation, graph the related function, and describe the relationship between the roots, zeros, and the x-intercepts. So when I see this, I have to first write down the equation, then I have to do the graph of it from what I know. I know that the roots are at 3. So I go over here, I jog 1, 2, 3. I know I have a double root at 3. So this is my vertex. My vertex is at exactly 3, 0. That's my vertex. And I know that it is opening upwards because this is a positive x. And I'm just going to draw a general parabola for the time being. Okay, 3 is the double root, so we're going to talk about that. 3 is the double root in our answer. And we have 1 0. And that is also at 3. This is the only 0. Whoops. And the only y-intercept. or sorry, x-intercept. I said that completely wrong. X-intercept, because we're looking where it crosses the x-axis. X-intercept. Okay, all of these terms are basically interrelated and mean pretty much the same thing. Okay, but the big difference is here. It's a double root, but it's only 1 0. Okay. Let's do this next example. It's part B of this one. Gives us the equation 3x squared plus 6x equals 0. Again, I can factor this. I can factor out an x because there's an x in both terms, so I do so. I'm left with 3x plus 6. What else could I have factored out of this? I could have factored out a 2, so I'm going to go ahead and do that now. So I have a 2x, or sorry, 3. I heard somebody say 3 and I said 2 and repeated. Sorry. So I can factor out a 3. So I'm left with just x plus 2. So that's really nice because then I don't have to do as much when I do my solving. First one, I set 3x equal to 0. And then I need to set x plus 2 equal to 0. When I divide this by 3, I just get 0 for x. When I subtract 2 on this one, I just get negative 2 for x. So it has, again, 2 roots. It has 2 zeros, and there are 2 x-intercepts. So I can graph this. The first x-intercept is right here at 0, 0. The second x-intercept is at negative 2. And the vertex is going to be somewhere below the axis. And there we go. There's my graph, and I already explained the relationship between the intercepts and such. Any questions there? Okay. This is the part of it that sometimes throws people for a loop. I hope that doesn't happen. But example 4. It says the quadratic has a relation that shows zeros at negative 5/3 and 1. So remember how we got these, okay? We set something equal to 0 and we said x is negative 5/3 and we said x is 1. So how am I going to get 0 back on our right hand sides? I have to add 5/3 on this one. So I get x plus 5/3 equals 0. And then over here I would have to subtract 1. So I'd end up with x minus 1 equals 0. So now these were the factors of the quadratic that it made. So I can write in those factors. So x plus 5/3 and x minus 1. And from there, I can rebuild my quadratic equation from the zeros. So if I wanted to make my life a little bit easier, I could get rid of that fraction first. And in order to get rid of that fraction, I just look for the least common multiple with the denominator. So I'm looking for the least common denominator is what I'm looking for. So I would multiply it by 3 to make my life easier. You don't have to do that. You'll still get the correct answer. But I would do it just to make my life a little bit easier. So I end up with 3x plus 5 being multiplied by x minus 1. Okay? So I would do that just to make my life easier, but you're not going to get it wrong if you don't do that. Okay? And then I just do FOIL. First times the first gives you 3x squared. Outsides give you negative 3x. Insides give you positive 5x. And then last give you a negative 5. And then combine like terms. My 3x squared just drops down. My negative 3x and my positive 5x make a positive 2x. Minus 5 equals 0. And that's my final answer. So you're just finding where the function goes back, in essence. Okay, any questions there? I hate that we're only doing one example, so if you want to do another one, we can. Okay, we'll do. So for the second one, let's just do a simple one that's kind of quick. Or do you want to do one with fraction? Fraction. Okay, so let's do 1/2. So let's say that the root is 1/2, and let's say that the other root was 1/3. Let's do 2 fractions. So remember, this is where x equals and where x equals. The easiest way to do this is just to take the opposite of that sign. So if I had x equals positive 1/2, I would write x minus 1/2 in my parenthesis. If x is 1/3, then x minus 1/3 for the inside of my parentheses. And since they're roots, I'm setting it equal to 0. Okay? Now here I'm looking for my least common multiple in my denominator. That would be 6. You want to do it with a multiple or without a multiple? Do you care? No? Okay. Let's just multiply it out then. X times x gives me x squared. Negative 1/3 x. Then we get negative 1/2 x. And we multiply the back, so we get positive 1/6 equal 0. Okay? I need to combine my like terms. So I need to change their denominators to 6 there. And in order to do that, I had to multiply this one by 2. I had to multiply this one by 3. So I have a negative and a negative, so that's going to get me a negative 5/6 x plus 1/6. That will equal 0. Now I'd want to rewrite this one afterward with a multiplying it by its common denominator, which is 6. So I'd end up with 6x squared minus 5x plus 1 equals 0. So all I did was distribute this 6 to everything. I guess I could. I just don't like looking at quadratics with fractions. They're confusing. Yeah, you'd still graph the same exact equation because your zeros will remain the same. So you're good? Last example then. Application of vertical motion. This is the one that's going to throw all of you to the wayside, so please pay attention. The height of a free-falling object is given by the function the height of, in accordance to time, is negative 16 t squared plus velocity multiplied by time plus height. Okay, it says the initial velocity in the initial height in feet is h sub o, and the initial velocity in feet per second is v sub o. How long does it take for an object to hit the ground when thrown straight down? Thrown is velocity, so I'm going to start plugging in here. Velocity of, I lost my spot, I'm sorry. How long does it take for an object to be thrown to the ground straight down at a speed of 20 feet per second, so 20 feet per second from a height of 84 feet. 84. Now, it didn't give me a time, so I'm going to go ahead and plug in my times for just t. 84. It gave it to us as 84. So all I did was plug in the information that they gave me, and all they gave me was this velocity and the height. So it said it's thrown straight down, so what we're trying to figure out is if it gains velocity or if it loses velocity or whatever it's doing. So this is how much feet per second it will be losing. This is the time, and it gets squared. So what they want us to do is, when is it going to be equal to 0? As in, when is it going to hit the ground, right? So I set this equal to 0 because I want to know when it hits the ground. So pull out your calculators. If you don't already have one, go grab one. And in your calculator, type in the equation y equals this little bit right here. Get mine out so I can type it in too. X squared is fine. It doesn't matter what variable you use. Just whatever you have easiest to use. So here's what I put in. I put in 16x, or negative 16x squared plus 20x plus 84. Make sure you use the negative sign. Okay, if you don't use the negative sign, you're going to get an error. Yep, I pressed graph, and my graph looks a little weird. I need to zoom out. So I'm going to change. I'm going to go ahead and change mine really quickly. If yours is good, then don't worry about it. Okay, zoom fit will work. I'll do zoom fit. See what happens. So there we go. The only reason I don't like zoom fit is because it gave us a lot of the bottom, which is not important to me at all. I really want to see right up here. So I'm going to zoom in to the vertex, which is way up here. I'm going to zoom in to the vertex, or near where my 0 is, because that's the interesting part too. So there we go. So there's my graph. This is what it would look like as it decreased in height. So this is what's happening to my object. So in order to find this, I press second calc. I press second calc. I press zoom, fit. And then I zoomed in on the spot that I was interested in. I just went to zoom in there. Yes? So from here, I press second calc, hit the 0 button. Left bound just means left of where you think it crosses, so I'm already there. I hit it. Right bound just means right of where I think it crosses, so that's just below on this graph. I hit enter, and then guess, where do you think it crosses? So I'm going to go right about there. Wherever I can get closest to y being equal to 0 is where I'm going. Blam. So it's right there. My 0 is at 3, 0. So there you go. So my x represents t, right? Because that's what we put in place of t. So my time would be 3 seconds. So I have a time of 3 and a time of, on the other side there's another time that's associated with it. Anyways, time of 3. So I'm going to put that in. At my 0 would be at positive 3. And the other one, if I moved on over, it would be somewhere in the negatives, I'm sure. So it is not important to me because it's a negative and it doesn't help with answering the question. Okay? So I don't really need the other 0. The other 0 doesn't make sense with the problem. Any questions? On this example, it was going down at 20 feet per second. So it would be a negative 20. You'd still calculate your 0 the same way, but it's a negative 20 because it's going down. My bad on that one. That makes a lot more sense.